This week, we are going to re-look at some connective tissue, specifically cartilage and bone. In this first lecture, we're going to look at cartilage specifically. A reminder of some general features of cartilage. It's tough and flexible. It acts as a shock absorber. It is avascular without innervation. It's involved in formation of bone, and from nutrients and waste, since it doesn't have vasculature, it has to obtain these through diffusion via a specialized extracellular matrix, which then you could see there's some challenges with tissue repair. Cartilage forms via embryonic stem cells or mesenchyme cells or mesenchymal cells. These cells migrate, and this is kind of their commitment step. They migrate and become their chondrocyte lineage or chondroprogenitors. They then condensate and proliferate and then differentiate into chondroblasts. And these chondroblasts are what mature into full chondrocytes. The blasts of cells, reminder, make stuff, and the cytes are going to be cells that support tissue. Now, the extracellular matrix that surrounds cartilage is more than the cell volume in this tissue, and it's quite hydrated with glycosaminoglycans. This allows for diffusion of stuff and substances throughout the tissue. It also makes cartilage more pliable, resilient, and shock absorbing. But the fibers involved are type 2 collagen fibers, which give cartilage its firmness. Now, there are some exceptions in that some types of cartilage have type 1 collagen or even elastin in them. I mentioned before that our cartilage is avascular, and that is true. So chondrogenic stem cells at the edges of cartilage will lead to become inner chondrogenic perichondrium, and the surrounding stem cells, which are mesenchymal cells, will differentiate into fibroblasts and form the outer fibrous perichondrium. And the fibrous perichondrium contains blood vessels and provides nutrient support to the nearby chondrocytes. So how does cartilage grow? We have an outer fibrous layer of perichondrium and an inner chondrogenic layer of perichondrium. We can see two types of growth then, apositional and interstitial. In apositional growth, our chondroprogenitor cells from the inner layer differentiate into chondroblasts. They then divide and add cells to the extracellular matrix. This is growing on the edge of cartilage. This is the edge of cartilage growing. Interstitial growth, chondrocytes in the cell and the core divide. They undergo mitosis, but they do not separate because the extracellular matrix solidifies. And then we see these then isogenous groups are formed, or these cellular nests. And this helps with bone growth, but it is different than cartilage growing from like its outer layer. There are three major types of cartilage to note. Hyaline, which is made up of type 2 collagen. Elastic, which has type 2 collagen and elastin, elastic cartilage. And fibrocartilage, which has both type 1 and type 2 cartilage, or collagen, excuse me. When we look and compare and contrast, we can see the chondrocyte arrangement is similar in all, but in fibrocartilage, we have parallel rows. We have the locations of where you would find these types of cartilage located here, and then their primary function. We see that hyaline cartilage provides shape and flexibility. It also models for bone growth in the fetus, and it's a smooth surface for bone movement. Versus elastic cartilage provides both shape and elasticity. And resistance to compression and cushioning and tensile strength comes from fibrocartilage. Looking at hyaline cartilage a little bit further, it's basophilic due to the sulfated glycosaminoglycans in the matrix. They are in isogenous groups. We can kind of see this here. It provides shape and flexibility. It has a perichondrium on either side. And the exception here is articular cartilage and the epiphyseal plates of long bones. Articular cartilage is a type of hyaline cartilage, and it forms the contact surface between bones and acts as a shock absorber. It's unique in that it does not have a perichondrium, it doesn't have capillaries for nutrients, and so it's maintained by synovial fluid, which contains the nutrition it needs. Elastic cartilage, as we can see here, has more elastic fibers. It contains type 2 collagen and elastin. It's also a basophilic matrix, multiple elastic fibers present. We can see those running throughout. We do have those isogenous groups, and there is perichondrium that surrounds this area. This provides both shape and elasticity. And lastly, we have type 1 and type 2 collagen fibers in fibrocartilage. The chondrocytes are arranged in these columnar rows, as we can see here, that are located between alternating level layers of hyaline cartilage and dense type 1 collagen fibers oriented in the direction of stress. There's elongated fibroblasts present and no surrounding perichondrium. This tissue really resists compression and provides cushion plus tensile strength. So this is a great kind of compare and contrast table that you can go through. This is from Med Boot Camp. And you can see here that you can fill in, what are the steps here? Embryonic, mesenchyme, migration and chondroprogenitors, differentiation into chondroblasts. So all the things in color are things that you could practice filling in the blank on this slide to practice and support your study. Same here. This is breaking them up into our different types of cartilage, hyaline, elastic, and fibrocartilage. So again, I encourage you to use these, all the color areas. The areas with color are areas to fill in to practice your skills. And that's our little deep dive into cartilage for this week. That should help you get through your lab and help support your learning and knowledge and connect some of the physiology to the histology.